going to review exam number 6, which you will take tomorrow. Topic number 1, Newton's universal law of gravity. Fg is equal to G m1 m2 over r square. I have a guest over here. We're going to find the gravitational force between me and him. All right. So here is Isaac. Isaac, can you draw you and that 1 meter away from each other? All right. Okay. Isaac, before I let you go, can you write your mass?
Let's say 40, and let's say...
I'm not 100 kilogram, baby. I'm probably like 50.
All right, let's go with a conservative estimate.
500 kilogram me.
Yes.
All right. Okay.
And wait, 50 kilograms? Yeah, sir. Okay, so let's go with the conservative.
All right, I'm cutting my trip to McDonald's. So yeah, pretty soon I'm gonna be 50. I'm telling you. All right, so let's. Isaac, can you estimate? Let's see whether you have a common sense. Testing your common sense without doing the math. And let me give you my true mass, 80. Without doing the math.
You do mean
no 800 80. All right. So put a power raised to 10. Just estimate. Guess.
I'm gonna say -8.
-8. Okay. Let's see how much. So
Wait, no.
You can.
Wait, no.
All right. What is it?
-8.5. Sorry.
Oh my God! You don't have to be like that.
I do have to be that. Wait, no, it's -8.
Okay, -8. Okay, let's see how precise you are. I mean, I'll give you credit if it is plus minus 1. Isaac, m me over r square, and the distance between me and Isaac is 1 meter, right? So G is 6 point. By the way, G is Newton constant. G is 6.67 times 10 raised to -11 Newton meter square over kilogram square, right? So 6.67 times 10 raised to -11 Newton meter square over kilogram square times Isaac times Dad over 1 meter square. All right, so let's see what's going on. 6.67 times 40 times 80 times 10 raised to -11 divide by 1 square, which is nothing, times you have Newton meter square, you have kilogram times kilogram square, and you have meter square, and you have kilogram square. Kilogram square, meter square cancel.
I'm one of the smartest people you'll ever. You
don't have to brag.
I don't know what I'm doing. 21,000.
It could be 21,000. 21,000?
Yeah, it's giving me -7.
Times 10 raised to 11.
Yeah,
so 2 times 10 raised to
-7.
-7 Newton. How much credit do you want to take? 1%, 2%, or 50% credit? Force.
Yeah.
On. So this is Isaac, and this is Mr. Bari. So force on Isaac by how much?
2 times 10 to the -7.
2 times 10 raised to -7 Newton. What is the name of this one?
F bearing on Isaac, which is also the same thing.
2 times 10 raised to -7. Now, this is very small force between these two bodies. How can we increase this force?
By increasing the mass.
Okay, how much?
Well, let's say you're the mass of the Earth and I'm the mass of the Moon.
Okay, so now can you make a guess just like before?
Then I'm gonna guess that it's
Fg is how much?
Then I'm gonna make a guess.
So FG is equal to GM Earth M moon over R square. So FG is equal to G 6.67 times 10 raised to negative 11 Newton meter square kilogram square. Mass of the Earth is 6 times 10 raised to 24 kilogram. Mass of the moon is 7.25 times 10 raised to 22 kilogram over 3.84 times 10 raised to 8 square. So what meter square? So Fg is equal to 6.67 times 6 times 7.25 divided by 3.84 square times 10 raised to negative 11 plus 24 plus 22 minus 16 kilogram Newton meter square kilogram square meter square. Okay, and this is going to give you 20, and this is going to give you 10 raised to 19. So Fg is equal to 2 times 10 raised to 20 Newton. So once again, Isaac is almost right. And this is your moon. Okay, so what are you going to call this one? You can call this one Fg. What do you want to call this one? You can call this one Fg. What else also can you can call this one? You can call this one Fc. You can also call this one Fc. What else also you can call this one? You can call this one F on Earth by moon. You can also call this one F on moon by Earth. And this one is 10 raised to 20 Newton. So this one is also 10 raised to 20 Newton. So you can call this one Fg, and this one you can call Fc. This one you can call Fg, and this one you can call Fc. Okay, so 10 raised to 20, the force 10 raised to 20 Newton on the Earth by the moon. And this one 10 raised to 20 on the moon by the Earth. Okay, one last thing. The distance between these two objects is 1 meter. And the force between these two objects is, let's say, I don't know, 16 Newton. Then if I increase the distance 4 times, 1, 2, 3, 4. Now put Isaac over here and myself over here, and distance is now 4 times as big. This is 1 meter, so this is 4 meters. What is the Fg? Fg would be 1 Newton. How? You can do it in 2 ways. One is Fg is equal to G m1 m2 over r square. Okay, so instead of writing Fg is G m1 m2 over r square, you can write G m1, which is what? Which is 16 Newton. 16 Newton. Because this is 1. Okay, this is just 1. 1 square is 1. All right. So then let's do this one then. This is 4 meters. And don't forget, this is, you're going to use this one pretty soon. So Fg is equal to G m1 m2 over 4 meter square. So Fg is equal to G m1 m2 over 16 meter square. Don't confuse with mass and meter. It's confusing. This is meter. This is mass. This is radius. This is mass. This is meter. So what do you see over here? Let's isolate this one. Fg is 1 over 16, and let's write whatever you see in the bracket. So G m1 m2 over meter square. Instead of meter square, maybe it should be, I just should write r square. That's better. R square, so that we can use this fact. Okay, so now what does that mean? Fg is equal to 1 over 16, and Gm1 m2 over r square has a value 16 Newton. Where did I get it? From here. So this one is this one, this one is this one, so I can replace this one by this. 16 cancel, so Fg is 1. This is Earth. Instead of you being over here, now you are here, you create a hole, you are in the center of the Earth. Okay, so what is the acceleration due to gravity on you if you are in the center of the Earth? Fg is 0, acceleration due to gravity on you is 0, is because, why? Because net force is 0. All the forces acting on you cancel each other. All the forces acting on you canceling each other. All the forces acting on you is like canceling each other. So, of course, we are assuming that the density of the Earth is uniform, and the Earth is made of matter, and every single matter is pulling you from the center of itself. All right, so what does that mean? This one cancel with this one, this one cancel with this one, so the net force would be 0, so acceleration would be 0, everything would be 0 if you are in the center of the Earth. Okay, now, however, if you are, on the other hand, if you are, this is Earth center, if you are above Earth, like one radius above Earth, this is 1 Earth, this is 1 radius Earth, you are here, I don't know, for some reason you are in the International Space Station, or somewhere you are in the satellite. So how are you going to grab that? So let's grab this one. Our x-axis is r, which is the distance between two bodies, center to center, and this is the force. Okay, so if you are here on the surface of the Earth, you are 9.8. Okay, we are taking the absolute value. And if you go, like the more you go above the Earth, the acceleration due to gravity on you is smaller and is approaching to 0. And this one is not going to be impossible to prove from the center of the Earth. Okay, if you move from center of the Earth to the surface, all right, that would be a kind of a diagonal line, because the center of the Earth, the force is 0. Force is 0, and over here, okay, the over here is well, 9.8 times m. Let's say 10 m. M for mass. So just write mg is better to write mg. Now, if I don't write mg, it doesn't. So m and g, let's write g. G is equal to -10, all 9.81. Okay. So here your force is 0. Here your force is -9.81 times your mass. Okay. As you move up, this increases. And as you move away from the surface of the earth, all right, the force decreases and approaches to zero. That means if you are infinite distance away from the earth, infinite distance away from the earth, then the force would be close to zero. Is centripetal force, and centripetal force is MAC, and AC is V square over R. So if you are here on the earth, right? Okay. Not here on the earth. Say this is a circular path, and there is a car moves on this circular path at location A. At location A, and the car is at location B. So the car moves with velocity, let's say 100 meter per second, radius 10 meter. Let's see what else. Mass of the car is 1,000 kilogram. Let's see centripetal force. Centripetal force is let's find centripetal acceleration first, V square over R, and that is V is 100 is square, so 1 2 3 4 over R, which is 10, so it's 10 cube meter per second square. FC is MAC, and that would be M is 1000 times 10 raised to 3, so 1 million Newton. Let's draw a acceleration vector. Let's draw force vector, twice the size. Let's draw velocity vector. Let's draw velocity vector. Okay, that's pretty much it. Okay, and one last topic is the jumping up. So I'm going to do it quickly. This is location A, this is location B, and this is location C. If you crouch, I don't know, 0.2 meter to have a jump height, let's say 0.3 to have a jump height 0.9 meter. Let's see, to have 0.9 meter jump height. Then your velocity over here is 0, your velocity over here is 0, your velocity over here is, let's find it out. If I somehow do this one 2 and this one 8, the velocity would be 4. Okay, and your acceleration over here would be what? Your acceleration over here would be 40. Okay, now let's use the Newton's third law. So this is Earth, and this is U. This is Fg, force on Josh by Earth. And how much is that? Josh is, let's say, 60 kilogram. So it's 600 Newton. Okay. Then G prime is also 600 Newton. We're going to call it force on Earth by Josh. Force on Earth by Josh. Okay, what else? This one, we're going to call it F push. We're going to call it force on earth by Josh. We're going to call this one, this is acting on earth, and this is acting on earth, so I'm going to use the green. Force on earth by Josh, and this is acting on Josh. This is 600 Newton. This is Fp prime, force on Josh by earth, and by Newton. Okay, so now we can separate them very quickly. Separate them. Let's separate them. Let's draw Josh. Okay, what two forces acting on it? Fg, 600 Newton. F prime P, we're going to try to find it. So F prime P is equal to mg plus A. F prime P, m is 60, g is 10, A is 40. F prime P is 50, so 3000 Newton. Okay, so now we're going to quickly do the earth. Okay, so if this is like this, so this is earth, and then this one would be F prime G has to be 600 Newton, and this one would be Fp, which is 3000 Newton by Newton third law. Let's find the acceleration. To find the acceleration, we have to find the net force. What is the net force? F net is equal to F net, Fp, which is 3000. So F prime P minus Fg is equal to F net. So 3000 minus, what is it? 600 is equal to F net. So F net is 2400 Newton. Now acceleration is F net over mass. So acceleration is 2400 divided by 60. 0, 0 cancel. 40. We knew that already. It's not a big deal. But let's find the earth. Acceleration of the earth is, this is acceleration of Josh at location B. Acceleration of the earth at location B is let's find the net force of the earth. By Newton's second law, by Newton's third law, if the net force is 2400 over here, the net force is negative 2400 over there. Okay, so this one is negative 2400, so F net over mass, so negative 2400 divided by 6 times 10 raised to 24. So we have negative 2400, right, times, well, we can do this. Negative 2.4 times 10 raised to, oh no, 6 goes to 24 4 times. So negative 400 divided by 10 raised to 24. Give me one second. Yeah, Remo, we'll come in. Just give me 1 second. Okay. Okay, I'm done almost. So negative 4 times 10 raised to 2 minus 24. So negative 4 times 10 raised to negative 22 Newton. So over here, this is Josh, acceleration of Josh, and this is acceleration of Earth. Negative 4 times 10 raised to negative 22 Newton. Okay.